How many of you already stayed in the previous talk? But it's really something, it's like an evolution of what we just seen right now, because it is extending the IoT to another level. So I'm going to show you an easy way to execute your code. It doesn't matter if it is a Docker container, Arduino code, whatever it is. You can deploy it remotely just by using a remote over-the-air updates on top of your Linux machine. So it works on Raspberry. It works on generic Intel, generic ARM devices. It's going to work everywhere. You just need some, you need a bit of space. We are going to see the requirements, but not that much. It's more or less 50 megabytes in total of disk space, and a lot less in terms of memory. So who am I? I'm the CIO of Arduino. So Luca, you can see me online. My name is Mastro Linux. You can relate a bit that I'm in the Linux field in quite a lot of years already. I'm 34, but I'm already using Linux since, I think, 15 years ago, something like that. So here we go. You probably know Arduino because, you know, the microcontrollers, on that kind of thing. So you say, why Arduino is here? We are speaking about Linux. Linux doesn't run here. That's true. But Arduino is not just hardware. It's also software. So there is the Arduino programming language. And the Arduino programming language runs on Linux. And that's the big news. So you're able to write code in Arduino, so with the simplicity of Arduino, and start making IoT that still runs on Linux. So, I mean, I love Go, and we basically managed to move most of our architecture, more than 50 different microservices, to Golang. But Golang, you know, is inherently difficult if you want to just start something simple and blink an LED. Arduino is much simpler to do that. It's really 3 lines of code. It's setup, digital write on, and that's it. Nothing more. So I'm going to show you how this works and how you can make it work on IoT remote devices. So this was our problem to be solved. We want something that the user can quickly understand. So it has to be simple. That's the main goal of Arduino, because a lot of people blame us and say, this is a toy and doesn't work very well. And then we figure out that really huge companies like Boeing is using Arduino to prototype their products. Or the same happens to Rolls-Royce or many other big companies that I cannot mention. Some of them I can, like Intel, is using Arduino inside. So, you know, really serious business application start using Arduino because it's simple. What's the goal here? Because everyone loves simplicity, because we are all lazy programmers, no? So if it just works, click, 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 we are happy. It's fine. Then we want to check the status of the system remotely. How many times you had something that is working somewhere else, as we had just seen. And we need to verify the logs, and I don't know if my Raspberry Pi is alive or not. How can I do that from remotely sitting on my sofa while my Raspberry is on the field? It starts to be complex. You need SSH double tunnels, reverse proxy, all that kind of things that are quite annoying usually. And then once you have big latency, it's going to be super slow, and you type something and you wait 2 seconds for the round trip, and it's just annoying. Then you want to install new packages on your remote, whatever it is, Linux device, because you created your own Yocto distribution, or you just want to deploy containers on the fly by using a web interface. Because sometimes you cannot have direct SSH access to your machine. And that's especially true if you have IPv6, or so some gateways doesn't support it, or if you don't know the IP address of your remote Linux device, how can you actually reach them? You either use something like ngrok, which is cool, and it's a proprietary service that allows you to basically proxy some part of your local machine to a remote server, and you don't know if actually someone is, I don't know, sniffing all your code, or how it works with your custom domain and proper SSL encryption. You cannot. You basically are relying on having a kind of nice IoT, which is OK. It's funny, but it's not production ready. We want to be production ready and be secure, so it is impossible to send data in clear with our own system. And you can do with your piece of code completely open source. So there were a lot of solutions to remotely manage servers or machines. So it's not the first time that someone is trying to solve this problem. It's all the same old problem solved in many different ways, the same old solutions. Some of them are really good for the specific use case they wanted to solve, but it was not OK for us because we are working on small embedded devices. It needs to be fast. It has to be HTTPS only, so I cannot never allow anyone to send packets in plain HTTP in Arduino because there is my face in the company on this side. No, now we are CISO, so it's tough, but still, we don't want to send public data anywhere on the internet, so it has to be HTTPS only. So you can have your own domain and so forth. And a lot of UDP ports somewhere if you want to manage your service, and you are passing through some local routers or proxy and whatever it is, they don't allow to use UDP protocols most of the time. So there are a lot of technical legacy constriction that doesn't allow us to make the IoT as we would like to have. Like all IPv6, all UDP, and we are all happy. No, it's not the case. We have to deal with bullshit of the past. So no UDP, no IPv6, just plain old IPv4 and TCP. We have to deal with it. No story. So there are some solutions that allows you to basically, I don't know, update, install packages remotely. There are also professional solutions provided by, I don't know, Red Hat, which is like super nice to manage trillions of devices and servers, professional servers, and so forth. But also there are some other interfaces to, like WebMin. If someone was in this field in the 90s, there were a lot of virtual hosting and hosting companies that were relating to something like WebMin. They are all solutions to manage remotely a server, but they don't fit our use case at all. And like this one, this is a solution provided by Canonical, which is really nice if you are managing servers, which is absolutely not nice if you are managing, I don't know, a cluster of Raspberry Pis. Why? Because they store your data, and then you have a synchronization problem. So you can see all the packets that you want to install are installed on your service. They store a complete mirror of the database of your apt get list. They check if they are both synchronized, and just in case, if you want to install something remotely, they send the packets back to your device and install everything. It is OK, but to scale it to billion devices, because we are not now talking, the IoT is made by billion devices. Some huge companies already last year sold, just one big company last year sold more than 5 billion devices in the IoT market. Just one company, one of the biggest, but still. So we are speaking about billions of devices, and you cannot just have a database unless you are probably, I don't know, Amazon, Google, or whatever it is, but we are like 70 people company. You cannot have enough resources to manage this huge database. And on the other side, those costs have to be covered by your users. So it's going to be scaling by letting your customer pay for the service quite a lot of money. It was OK for us. Even if the interface was nice, you can see the list of packages, you can install them remotely, install security upgrades, and everything like that. So nice idea. Doesn't scale well for our use case. Zensial is a solution for small medium business. I'm just going to check the, for medium business, it doesn't fit a Raspberry, or even if it does fit a Raspberry, why you would need a custom OS just to use a small portion of their feature? Do you really need a Samba server pre-installed? Maybe not. So why cannot you use your own custom OS? And again, similar interface. You can see what is running, the services that are running. You have some monitoring system. So we are really in the same direction, but some pieces are still missing. Then there is a Agent, very similar, written in Python, a bit more modular. But again, HTTP server-based. What's the issue here? That to reach your device, you need to know their own public IP. This is not always possible, just simple like this. Or if you are running with a dynamic IP, you either rely to something like that is following your dynamic IP and changing, or you cannot really do that. And you cannot use your custom domain on top of it. So not a deal. That's why we released this piece of Golang software, public and open source. I'm going to give you the links later. It is just one single binary, everything in it, no external dependency, is going to run everywhere, ARM, Linux, Intel, whatever it is. We are also trying to have it working on not just Linux, but now it's on Linux. And it works on x86, it works on ARM 7, ARM 5, ARM 6, ARM 8, whatever you like. Secure-only connection, it uses MQTT. MQTT is like, no one likes it, but everyone uses it. Because there isn't really anything so better than it. So it's like, you like it? No. But you use it? Yes. OK, that's fine. It works on low connection. And you don't need to know the IP. What is the trick? Why? How I can connect to a remote device if I don't know the IP? The other way around. So I declare a public domain, so something iot.arduino.cc, and I let the device declare it when it is alive to something else. And boom, I open a socket. A socket is a TCP stable connection, always open. And now there are a couple ways that you can make MQTT scale, sort of. But still, kind of working. So we need some protocol that has to be simple, works on small devices, is relatively fast. It has a lot of features like automatic reconnection, keep alive, check of the payload, and that kind of thing. So there are some that are super fast, like protobuf, and a lot of features, but they don't really run on super small embedded devices like protobuf. Then you have HTTP that everyone can understand, but it's not really super fast because it has a lot of boilerplate around. Then there is co-op that is based on UDP with all the issues that we have seen before. So this is only what you need on the server side if you want to run your own version of this software. So we release open source the client. On the server side, you can use just a plain Mosquito or VernQ or whatever MQTT browser you want, broker you want, or just use something provided by the main cloud vendors like Amazon, Azure, or Google. You need an MQTT server. You need SSL support. The MQTT client can be whatever you want to have. It can be WebSocket, MQTT over WebSocket, JavaScript libraries, Python libraries, Mosquito client. Doesn't matter. It works. It's just plain MQTT. And eventually, but this is optional, you can disable it. You have the source code, so do whatever you want with it. It's like Apache 2 license. It just works. And if you have a no-out server, we also have a way to identify the users and basically, trust really that the user that is acting on the system is exactly the one that wants to act to the with the system. So yeah, I'm a manager, so everyone say, okay, but show me the code, because you are a manager, you are able to speak, but not able to code. But I am able to code, this is nice. So this is the code, it's the Arduino connector, and it is, that's the GitHub URL. So I said it works on ARM v6, 5, 6, and 7, and 8. So obviously in the 8 version is 64-bit. The same for x86. But this is not thanks to us. This is thanks to the Golang toolchain. We just wrote the code. What we really put some effort in was in the serial communication and in some internal things that we released open source again. I'm going to speak about them later. But it basically almost came for free. And here is an example of calls, MQTT calls, to get some data from your device. So you send a post to /stats, you get information about your memory. Or you want the list of apt repository, apt packages installed, you launch apt list post, and that's it. And as it is clear, now as an example, we are using the MQTT broker provided by AWS, but you can use whatever you like. What's the idea behind that? Something that is super easy. And everyone knows, and I'm not going to tell you because you know much better than me, but in Linux, everything is a file, exactly. So you have /proc, and you have all the information you need under /proc. So, it's just the kernel doing that for free. And in the last something like 20 and more years. So you just read the /proc /meminfo, and you get some data. Then we put everything in a Golang map, and we expose it on an API. As simple as that. So we released this Go system stats to retrieve some statistics. It's not as huge as some other super interesting projects because it had to be small, really small. The same for getting information about your apt install packages. If you want to see the list of all your installed packages, what can you do? It's just apt search and something, and you can get the list, or dpkg-l, and you have the full list of packages installed or not installed on your system. And you have an interface like this one. So I can search for a package, I can click update all, and it's super simple. No more SSH inside it. I mean, it's nice, it's fine, because you look very cool, especially, in some movies about hackers, you have this terminal, which is cool. I mean, I love the terminal as well. But sometimes, just a green button is nice. Just click it, and instead of running apt-get upgrade and update and end apt-get upgrade, I can run this. It does the same thing. This is on a web page. I'm going to have a live demo because it works also with the Wi-Fi of the hotel, which is, working for real. We also were able to have network manager integration, so you can remotely change the configuration of your network. But if you think that I'm saying just bullshit, this is it. So this is my machine. It is online right now. This one is offline. So if it is online, I can click on it. It loads something. And I'm remotely managing whatever you like. This is an Intel generic. Can be a server, can be an AppSquare, can be a Raspberry, doesn't matter. You have the gigabyte of space disk available, the RAM. Obviously, it's super simple, and probably if you are a pro sysadmin, you are not going to like it. But for a novice that just want to play with IoT, is perfect. This is, you can see there is a Wi-Fi connected. If I click here, I can see what is my IP address. So how many times you had to, I don't know, get the MAC address of your remote devices. It was pretty annoying, or know the IP address. You have the device that is telling it to you, not the other way around, not you asking your device to get your data. And you can also change the network. Obviously, if this is going to be the only network available, and you make mistake here, you're going to be out. But if you have multiple interfaces, you can do that with no problem at all. So if you have both an Ethernet, let's say, and a Wi-Fi, or two different Wi-Fi, we support it. Then don't look at the containers. I'm going to tell about that a bit later. But look at the packages. Now, as said, a lot of systems already have this sync, everything synced remotely in a huge database with your own list of packages. This is taking a bit long, because what it's doing is running a dpkg-shell on my system. I report back all the data by using MQTT. So there is Raspberry sending data to the server, and then there is a MQTT WebSocket client running in my browser that can read all the data. And again, I can just install, I don't know, Firefox local AN, click here and install it, and it's going to install it. It's really super simple. Or I want to add a new repository. I can do that. Just put it here on apt line. Or I can edit those configuration. What is nice about this? That it scales almost indefinitely, because we don't own the user data, because they are just passing through the MQTT broker, but they are just passing through. But if you have your own MQTT broker, feel free to run it. So we don't store user data at all, just passing through, and everything is encrypted in HTTPS, and on the client side, there is also HTTPS involved with a proper certificate in the client. Then, and here is the magic, you can start Arduino processes in your Linux machine, like this. OK, it's running. OK, where is the code of this? I'll just click here, open it in our web IDE. Just taking a bit. This is the code, and it's acting as a Linux. Sorry, as a Linux process in my machine. If you don't trust me, you can see here there is the connector, the MQTT thing. And maybe I also had, I don't know about the naming convention. Oops, we used. But here there is also a sketch that is running, which is nice. I can do this is owned by root. Now it's going to give me an error, obviously. And here it is. OK? And I also do, oops, my fault. As you can see, this is a binary executable, but it is indeed a C++ application. We compile it online. We deploy it by using MQTT on your remote device. And how can you do that? You select this. You click upload, and it uploads by using over-the-air updates. Super easy. So you can actually write Arduino code on your Linux machine by deploying it over the air. This is IoT. So no bullshit. It's working. It's in production already. It's still free for a while at least. Or if you don't like ours, everything is open source. Do your own. Just use our technology if you like it. Containers. No, you are saying really that I can deploy containers remotely? I cannot trust you. You cannot trust me. That's nice. Let's deploy. Let me check. I hope I don't have Nginx. Let's remove this one. And now, because I also don't trust myself, let's do a Docker. Yes. Maybe it's dash it's dash A, something like that. Okay, so there are no Nginx here, okay? One exited 2 months ago. Nothing here. Cannot see. Deploy container. Is looking for Docker Hub. And if it finds something like this specific name, or you can use your own private image, you click deploy. Oops, sorry. You click deploy. It is deploying. Still not running. Now it's running. Ta-da! It's working. So I'm deploying by using a web interface on WebSocket and MQTT. Ooh, super nice. Again, this is production ready. This is not a toy anymore. We work hard for having this. But I think it's really, really changing a bit the space of the Linux IoT. And now what we are working on is also to change the way our users think about the IoT more in general, because people think about having properties of their system. So we want to expose this simplicity to the users. And even if no one actually knows that this interface exists, I say we can offer, as of now at least, and I think for a while as well, everything for free, is because this costs basically nothing to us other than the MQTT server and the data transfer. Everything else is no storage. Super simple. Keep it simple. The more I study everything that is super complex, like I'm not a kernel developer because it's too hard for me. I cannot understand. So I try to simplify everything and have things that are simple for our users. So if I want to start my own cluster of things, oops, like, yeah. And again, if you don't trust me, Docker PS, and just starting everything else. Okay? So you basically have everything. Sketches that are C++ files. Imagine what you can do. Containers. You want to run your node applications, fine. Just use it. You can configure the network and have some statistics. Obviously, this is just the start. So we released that basically 6 months ago. Now we are seeing some traction in the users. Already 600,000 users are using our web IDE. But imagine the potential is everyone starts building their own tools on top of this. Now, what is the beautifulness of Linux? That, and this is an issue because Golang doesn't have C++ binding natively. It has for C, but not for C++. And if you look at APT library, they only have a C++ binding or Perl, but we don't use Perl anymore. So we have to deal with a command line. So we basically made a wrapper. I know this is not perfect, poorly speaking, but it works consistently because the CLI, the Linux CLI, is extremely stable. If you can remember, what is the last time that someone added a flag in the ls command? It's been ages ago. So ndpkg --configure-a is still supported and still completely valid. So the Linux command line tool is a super stable API because everyone is using bash. So it's not going to change and break things in production. OK, now I can assure you I'm going to stop and show you some more technical details. So this is the Go Network Manager to, as I said, manage the Golang. And we also do some extra checks. So if you don't have Docker already on your target machine, we install it for you because we have the apt-get install, whatever it is. So we do that. Then obviously with Go, we use the Docker API client. Why is that? Because Docker has been written in Go. So you can imagine that the first client they implemented was the Golang one. And that's why we are using that, and that's why it's working extremely well. Works with private registry. So if you want, you can use your own Docker container and do whatever you like. And we tested it on Intel data centers with really huge, massively huge 64 cores, but even bigger Intel servers. We tested it on BeagleBone Black, it works, or Raspberry, and even on smaller devices. So it really doesn't matter the size of your device. What is the other nice thing? That you can play directly with the hardware by using Arduino. So what we just seen in the previous super awesome talk about Go accessing the GPIO. Accessing the GPIO by using Arduino is even much simpler. This is an example. I'm going to show you. There is a full tutorial about this. This is an app square that has the same Raspberry Pi pinout, but it has an Atom inside. So it's basically like a Raspberry, but with an Intel chip. So with this pinout, we can basically have something that is requesting the status of the Ethernet and eventually blinking an LED. But blinking an LED also means, I don't know, if the Ethernet is down, just send me an alert somewhere in the world. And here is the code. It's like 6 lines. So I declare a string. I run a shell command in Arduino API. So there is this system API. And this system API is portable by using MRA on more than 80 different hardware targets using native API of the hardware behind. The MRA project has been mainly promoted by ARM and Intel together, but there are other companies supporting it. Then you can do something like digital write, name of a pin, high. That's it. Name of the pin, low, and we'll shut it down. So, it's using internal pins. It also works on microcontrollers, so you don't have to always flow by using the GPIO. Why? Because GPIO are extremely slow because they have to deal with the kernel, wait for it to grant them, do something. But if you have a microcontroller, you can directly interact with the hardware. So you can really have, let's say, near real-time communication. If you want to see the whole code of this, oops. This is the hardware. There is some description. This is the whole code. So I define some pins. Obviously, this is a pure example. But we are also able to run like OpenCV or OpenVINO, which is the Intel library for OpenCV, directly running on Intel servers by using Arduino APIs. So you basically have OpenCV run, and it runs everything. We also had some porting for Intel itself for the MKL library, which is the math kernel library, and is extremely powerful in like inverting matrix. And you still program in Arduino to invert matrix. So with the simplicity of Arduino, doing super complex thing by using the full power of your system behind it. So here is the code. You can cobble it. You can open your own workspace. This is free, and we stay free. You want to kind of clone it. You add to your sketch. And bam, you can play with it. Here it is. And I can deploy on my Linux machine. Yes, I can. I just have to upload over-the-air update. And done. Now I can see probably it running. Where is it? Sketches. And it is running. So here is the story. I really, really hope you have some question about this. Thank you.
Okay, thank you, Luca. Any final questions? Okay.
So you have said that Arduino Cloud is free of charge.
Yeah.
Aren't you worried if Arduino decide to shut down the system or change something, you were in trouble, or they can shut down your entire system?
They, you mean me, because I work for Arduino. But yes.
Yeah, but
more in general, you can use, I say, your own MQTT server, run it whatever you like, and it's yours. So you can base it whatever you like. Obviously, we are going to have some of the future as paying feature, especially for professional use. Like if you use a private repository, you are probably a company. If you don't want to have your sketches publicly available and you want to have it closed so you are not really completely contributing to open source, you are going to pay. So our idea is very similar to how GitHub works. No? If you have everything public, it's going to be free. As soon as you want to lock something out, you are probably a company, and then you pay. So this is our, our main goal. But what I'm saying that we are never going to do is to sell data of our users. We are also completely like GDPR compliant, so everything is obfuscated on our server. We are not even storing plain data about our user in our database. So there is no way to sell data of our user. So, yeah.
The second question. Are you able to do the things you've shown on with one action to 100 devices, or you have to?
No, it is possible, and that's why. And it's a good question, actually, really good one, because you remind me that it's something I didn't spoke about. But we released a couple of in August. At the end of August, we released this thing, the Arduino CLI, the command line tool, that allows you to basically also compile locally and do many other things. And the connector, so something that we have just seen, has an option. I'm going to show you. It should be here. As an option, don't remember. We can actually check this. Yes, is Arduino connector. There is this install flag. So you can call Arduino connector install, put everything in Bash, in Ansible, whatever it is, and pre-register 1,000,000 devices. Because the only thing that it's doing is creating this configuration file. And it has the ID of your user, the URL of your MQTT server. If you are using an HTTP proxy, you can put everything here. And eventually, because we use OAuth 2, there is also, some endpoint to deal with OAuth. But yes, you can do that.
Okay, other questions?
No?
Anybody? No? Okay, so thank you again, Luca.
Thank you, everyone.
Thank you.